Thank you everyone for joining me today. Welcome to another presentation in Chemsafety's online webinar series. Today we're going to be looking at managing solvent exposure in the workplace. My name is Paul Robertson and I will be your presenter today. So here's a quick run through of the topics that we will discuss today. We'll firstly look at the chemical properties of solvents and why they are useful substances in the workplace. Then we'll look at health effects of solvent exposure to see why we need to protect ourselves. We will then look at how solvents can get into the body and move on to some common solvents in situations where solvents will be used in the workplace. I'll also talk about options for controlling solvent exposure in the workplace, and I'll talk specifically about vapor degreasing and how improvements can be made to degreasing operations to lower operator exposure. Then in the case study section, I'll talk about a sad situation where a carpet layer died after solvent exposure and the findings of the court case that resulted. Finally, if you're watching our webinar live, there will be a Q&A tab at the bottom of the screen. Feel free to submit any questions during the presentation. Then at the end, we'll run through them. Our details will also be sent through on a follow-up email with a link to the recording of today's session and some other online resources. So let's get into it then. What are solvents? A solvent is a substance that dissolves a solute, resulting in a solution. Solvents are usually liquids, but can also be gases, solids, or supercritical fluids. Water is the most common solvent, but as water is typically well tolerated by humans, we're more interested in organic solvents in this webinar, which have much greater potential to do harm. When you hear me refer to solvents during this webinar, I will be talking about organic solvents specifically. Organic means containing carbon, and organic solvents are commonly used in a number of workplaces. So let's look at some of the types of products that contain solvents. Solvents are used in almost all workplaces and are used a lot in the printing, manufacturing, automotive, painting, agrochemical, cosmetic, and pharmaceutical industries. Common solvents used in the workplaces are found in adhesives. They contain solvents such as cyclohexane, acetone, and toluene. Paints and lacquers contain toluene, xylene, methylethyl ketone, otherwise known as MEK, among other solvents. Tetrachloroethylene and trichloroethylene, some of those, tetrachloroethylene is also known as perchloroethylene, and sometimes you hear trichloroethylene referred to as trike. They're used in dry cleaning and degreasing operations. Printing operations use many different solvents, such as turpentine, white spirits, and xylene, among others. So let's look at a bit of chemistry now to understand how organic solvents behave. Understanding the properties of organic solvents will help with the understanding of how we can use controls to protect ourselves from exposure that we'll discuss later in the webinar. Most organic solvents evaporate easily and boil at low temperatures. The boiling point of a solvent is determined by the size of its molecules, as well as by the strength of its intermolecular forces. Solvents with low boiling points evaporate easily at room temperature, and the closer you get in temperature to a solvent's boiling point, the more vapor is released. Think of how a pot of water boils on the stovetop. The closer that you get to the boiling point of the water, the more steam is released. So solvents behave in a similar way. With solvents, be aware that atmospheric pressure, so if you're working with solvents at high elevations, they'll have an effect on the boiling point. So using solvents at high altitude can cause solvents to boil several degrees below their normal boiling point. And as I said, the closer you get to the boiling point, the more vapor is released, so you could end up with a greater level of exposure. Some solvents are miscible in water, and other solvents will form separate layers. So miscible means that substances mix completely. If two substances are miscible, they are also completely soluble in one another. Let's move on to health effects to understand how exposure to solvents affect the human body. So let's start with how organic solvents can enter the body. So there are a few different mechanisms. The first one and most common is inhalation. So most solvents are volatile. That means that they evaporate quickly into the air. The vapors that result can be breathed in and easily pass through the lungs into the bloodstream. So this is the most common route of exposure, as I said, and it results in really rapid distribution of the solvent into the body. So ingestion, while some people choose to ingest solvents deliberately on a regular basis when they have a glass of wine or beer which contains ethanol, this is the least common route of exposure in the workplace. So ingestion can occur when solvents are stored incorrectly in drink bottles with no labels, so someone can accidentally drink from them. We don't see it very often these days, but we have seen a few cases of that type of behaviour. The other way solvents can be ingested are when people are working in high levels of vapour concentration, and the solvent droplets can actually form on the hairs inside the nose, and then they can be sniffed in or swallowed. The other way is mouth contact with contaminated hands, food or cigarettes. That can also result in the ingestion of solvents. One thing that we have to be very aware of with working with solvents is skin absorption. So solvents can be absorbed through the skin by direct contact with liquids and vapors and into the bloodstream in this way. Solvents that absorb through the skin are readily soluble in lipids, which are the fats of the skin. So there are a few different factors that mean that uptake through the skin will be different for different people and different situations. So uptake depends on the duration of contact with the solvent and the skin, skin thickness. So younger people tend to have thicker skin, dehydration rate, so how much water and sweat a person has on their skin, and the presence of broken skin. Phenol, which is a particularly toxic substance, can be absorbed through the skin in quantities sufficient to cause death. So when we talk about exposure to substances, we have to consider both acute effects that happen quickly and chronic effects that happen over a long period. So acute exposures, they take place very quickly. So what happens when people are exposed to high levels of some solvents is that they can get dermatitis or skin problems, so drying, cracking, reddening or blistering of the affected area. They can experience euphoria, so a feeling of sort of being intoxicated. Can also lead to headaches, drowsiness, so feeling sleepy, poor coordination, and nausea, so feeling sick. So in cases of exposure to very high concentrations of solvent vapour, unconsciousness and even death can occur. So it can get really serious if solvents are not controlled properly. So let's talk about chronic exposure now. So chronic effects tend to occur after long-term repeated exposure to lower levels of a hazardous solvent. These effects develop gradually, usually over months or years. Recovery once exposure stops is extremely slow and often incomplete. In fact, the effects are often permanent. So many solvents affect the same target organs as alcohol. So consider the types of damage caused to the body by alcohol abuse. When organic solvents get into the body, many of the same systems are required to process and flush them out of the body as alcohol, which can, put additional stress on those same systems. So the results of chronic or long-term exposure can be liver damage, kidney damage, reproductive system damage, damage to a fetus or unborn child, brain and central nervous system damage, and dermatitis. So the ototoxic effect of solvents is an important consideration when assessing potential health effects of substances on workers. In the latest edition of the New Zealand Workplace Exposure Standards, many solvents had the ototoxic notation added, as new studies into this effect provided information on this health risk. Ototoxins are chemical substances that cause hearing loss by inhalation or skin absorption of the substance. They can cause hearing loss without simultaneous noise exposure or worsen the effects of noise exposure. The hearing loss can be caused through a variety of mechanisms, with most of them damaging the components of the inner ear. Aromatic solvents such as toluene are known ototoxins and are suspected to chemically poison the hair cells within the inner ear. Other known ototoxins that are also solvents, so ototoxins are not limited to solvents, but we'll just talk about the ones that are solvents today. So butanol, carbon disulfide, ethanol, ethylbenzene, hexane, trichloroethylene, and I mentioned toluene earlier. But that's not an exhaustive list, that's just some that are commonly used in industries. When there is noise exposure in the workplace, more care needs to be taken around ototoxic solvent exposure. Industries where solvent and noise exposure are commonly combined include painting, printing, construction, boat building, fueling, degreasing, manufacturing, and furniture and cabinetry making. The health effects of ototoxin exposure include noise-induced hearing loss, so a cumulative effect from repeated exposure and due to damage to the hair cells in the inner ear. Tinnitus, so that's like a ringing noise or a noise heard in the ear without an external cause. This frequently accompanies deafness. Annoyance and stress, so when the hearing is damaged, this can be difficult to quantify and measure, but can also cause psychological effects such as poor concentration, irritability, and stress. So it's recommended that noise exposure of workers based on a daily shift exposed to any ototoxic substances be reduced to 80 decibels or below. They should also undergo audiometric testing on a regular basis and be given information on ototoxic substances, as well as controlling exposure to ototoxic substances where possible. So let's look at mixed exposures, because many workplaces use more than one solvent at a time. Consideration needs to be given to mixed exposures and the effect that these types of exposures can have on the body. So there are several types of effects to consider. Independent effects are when the toxic effects of each substance are unaffected by simultaneous exposure. So that happens when you've got two relatively different substances or solvents that someone's being too exposed to, and they don't affect the same target organ, so they don't have an additive effect. So when an additive effect occurs if two or more hazardous substances have similar toxicological effects on the same target organ or system. In this case, their combined effects needs to be considered. The combined effect of two substances is equal to the sum of the individual effects if each substance was encountered alone. So for example, toluene and xylene, both of these substances are irritant and narcotic. They're similar chemicals and affect the same target organs. So when someone is exposed to both xylene and toluene at the same time, the effect will be additive. So you can add, they're not working independently of each other. You have to consider that each effect is added to the other one. Synergistic effects, so this is when the combined effect of two substances is greater than the sum of the individual effects if each substance was encountered alone. For example, carbon tetrachloride and ethanol, these chemicals are both hepatotoxic, so they both damage the liver, but total liver damage caused by the combined exposure to both of these substances is much greater than you would expect than additive effects. So it's giving a much higher damaging effect than both of those substances encountered alone. So when we measure exposure in the workplace, we need a set of guidelines to compare to determine if health effects are likely or if exposure is well controlled. The Workplace Exposure Standards, or WES, provide a list of airborne concentrations of various substances that most workers can be exposed to repeatedly without coming to harm. These are set by WorkSafe New Zealand. It should be noted that some individuals will have greater susceptibility to some substances, e.g. If they have an allergic reaction when exposed. So the WES for a particular substance should not be considered as being protective for all people, and some individual assessment needs to be accounted for. Let's take a look at controls now to understand how we can best protect ourselves from exposure to solvents. So first, let's take a look at the hazard hierarchy of controls so we can see the order of the most effective controls. At the top, you can see that the most effective control is elimination. So that involves physically removing the hazard, so eliminating solvents from the workplace to ensure that no harm can be caused by solvents. This is an often difficult thing to do, so while it's the most effective, sometimes can be the most difficult. Substitution, this involves replacing the hazard. So with solvents, you'd look at the solvent that's being used and trying to find a less hazardous replacement solvent for it. Isolation, so that involves separating the hazard from the worker, whether it's all workers. So you might put a certain solvent operation inside an enclosure or a separate room to minimize exposure to workers. Engineering controls, so this is designs to prevent unwanted events or mitigate harmful consequences. So when we're talking about engineering controls, we're often talking about ventilation and local exhaust ventilation. So trying to remove the vapors from solvents before they can get to the people. Administrative controls involve changing how people work. So in that case, some of the controls that can be implemented are job rotation to limit exposure to individuals, and changing shift lengths and patterns to limit exposure. And then finally, at the bottom, the least effective but most commonly used control is PPE. So putting personal protective equipment on the worker to protect them from the hazard. So that for solvents involves using gloves and protective clothing and respiratory protective equipment to protect them from exposure. So as I said, we've got some different strategies for controlling solvent exposure. So typically in workplaces, it's easier to control a hazard at the person, but as we saw on the previous slide, this is the least effective option. So let's talk about ways that we can control solvents. These control options apply for most hazards we encounter in the workplace, and it's important to consider eliminating the use of organic solvents by either using solvent-free materials, and if this is not possible, then exposures can be minimized by substituting, so using chemicals with less toxic ingredients or water-based solvent substitutes, mechanical ventilation to increase the amount of fresh air into the work area, increasing natural ventilation by opening doors and windows, working outside or in the open. Further minimization controls include keeping lids on containers to prevent solvents evaporating, disposing solvent-contaminated rags in sealed metal containers, using only the minimum amount of solvent required for the job, scheduling working with solvents during cooler periods of the day and when fewer workers are nearby, never using solvents to remove paints or grease from the skin. So this is really important. Don't use solvents to wash your hands. They are very effective at taking off grease and paints, etc., but your skin will be damaged from repeated use, and obviously you can absorb these solvents through the skin. So lastly, use appropriate personal protective equipment. So using a suitable respirator with the appropriate organic vapor cartridges for the solvents used. Be aware that organic vapor cartridges do not filter all solvents, especially some solvents with very low molecular weights and low boiling points. So specific cartridges may be required, so don't just assume that an organic vapor cartridge will provide effective control of all solvents. So ensure the respirator is fit tested for the worker and also cleaned and maintained properly. So the equipment is only effective if it's well looked after and well maintained. We often see on site poorly maintained respiratory protective equipment. Some people don't store them correctly, leave them out in the workplace where they can be continuously exposed to solvents. So a lot of training and care needs to be taken around storage and assessment of the suitability of the respirator as well, because with continued solvent exposure, respirator parts will become worn and damaged. So the person wearing the respirator needs to know how to assess if their respirator is becoming damaged, know how to order different parts for it or when to replace it. Also, suitable coveralls and gloves need to be used to protect the skin. And again, similar to respirators, gloves, different types of gloves will protect against different types of solvents. And it's important to be aware of things like breakthrough. So after a certain level of use, solvents will begin to break through the gloves and get to the skin. So it's important to assess which gloves should be used for the particular solvent that's being used. So let's take a look at a common process that is present in many workshops and paint shops and see what controls can be added to lower the exposure to operators. For those that haven't seen this process before, degreasing is the process whereby all grease and adherent material is removed from the surface of metal prior to undergoing electroplating, galvanizing, tin plating, painting, varnishing, and other surface protection processes. In vapor degreasing, the solvent which is contained in a specially designed tank is heated to its boiling point to produce a controlled solvent vapor zone. The item or items to be degreased are immersed into this vapor zone, and the vapor condenses on the metal surface. The condensed solvent runs off the metal, washing away the impurities. The metal dries when it reaches the temperature of the vapor. At this stage, the clean items can be slowly removed from the tank. Without good controls, this process can lead to very high solvent exposures for the workers. As you can imagine, you're boiling a solvent, so you're producing the maximum amount of vapor. Typically, vapor degreasing uses trichloroethylene or perchloroethylene as the solvent. Just let's look at the different parts of a vapor degreasing bath so we can understand how the vapor is controlled and what can be done to improve control around this. So for many operations, the degreasing aspect cannot be eliminated, and the chemicals used can't be easily substituted. The following controls can help improve the system. So above the cooling coils, labelled as the water condenser on the tanks that you can see there, an open-topped vapor degreasers is what's known as the freeboard zone, so it's sometimes called the FBZ. There is some movement of vapor from the vapor zone into the freeboard zone. So even with those cooling coils, they're not going to stop all the vapor from getting into that zone. So if there's vapor in that zone, you need to think about minimizing turbulence across the surface of the bath. So make sure that you don't position these tanks near open doors because that will, airflow will blow vapor out of the tank and into the workplace. So adding rim ventilation is a really good way to control this. So what that does is puts extraction around the edges of the tank so that any vapors that are getting into the freeboard zone are mostly getting extracted rather than going into the workplace. It's important to have a correct freeboard area. So the ideal, so the freeboard ratio is defined as the freeboard height divided by the width of the open area of the tank. And ideally, you want at least a 0.75 to 1 ratio, and preferably a 1 to 1 ratio should be achieved. So also exhaust ventilation should be used to remove any solvent vapors from the load and unload zone. For open top vapor degreasers, ensure the temperature and flow of water through the condensing system is set correctly. If that is not, then you'll not contain your solvent vapor very well. Other things to consider are some training and for staff and potentially engineering controls around introducing the load too quickly or removing it too quickly. That can create excessive either push out of the vapor or drag out. So a mechanical hoist system set to slow speed can help reduce the speed that the loads are removed and put into the bath. And this also will reduce any manual handling. Loads should not exceed 50% of the open horizontal area of the plant. So this is to make sure that you don't push out excessive vapor when you introduce the load to the bath. When you bring loads out of the degreasing bath, they should be allowed to hang and dry in the freeboard zone until all residual solvent has evaporated. So this is not an exhaustive list of controls for vapor degreasing bath, but it gives you some ideas about how solvent vapor can be controlled in this process. So we're going to move on to a quick case study now. So we'll briefly look at what can go wrong if solvent exposure is not properly managed. The information presented in this section is taken from judges' notes from the resulting court proceedings. And in 2019, a carpet layer went to work laying carpet in a 6 metre by 3 metre office room. He was later on found unconscious by the building owners in the mostly carpeted office. There were 3 cans of solvent open in the area, the glue that he was using to put down the carpet. The building owners reported a really strong smell of adhesive fumes in the room where they found him. The windows in the room were partially open, but they could have been opened much wider. The contractor was taken to hospital, but sadly died the following day. So the company that employed the carpet installer was prosecuted and pled guilty to failing to ensure a safe workplace at all time for its employees undertaking work on its behalf. The company was fined $60,000 and ordered to pay $105,000 in reparations to the victim's family. So the changes made or planned following the incident in the company involved enforcing the use of hazard identification sheets, ensuring 2 people work together on some or most jobs, rotating workers to minimize the exposure time to toxic solvents, changing employment agreements to enforce use of personal protective equipment, and safety practices resulting in serious misconduct if they're not adhered to, ensuring all workers have a copy of the best practice guidelines, ensuring awareness of the danger of products by way of pictograms, asking workers for their inputs and suggestions to health and safety practice and policy, and engaging in a consultancy to undertake exposure monitoring and respirator fit testing. All workers were required to attend first aid training, and they worked on elimination of some of the solvents that they could. So what Chemsafety can do to help you with assessing solvent exposure in the workplace. So we can undertake qualitative assessments in the first instance. We can help you identify and risk assess your work processes and give you a list which tells you which processes are most hazardous. We can then move on to undertaking exposure monitoring to quantify any solvent exposure. We can advise on controls that can help you lower workplace exposure, and we can fit test respirators to ensure that they are appropriate for staff. So thank you for listening to this webinar today. I hope you found it useful. I'm going to move on to some of the questions that you submitted next. So someone asked, how do I know how long my filters will last for when working with solvents? So there are some calculations that can be done, but you need to know what the level of solvent exposure is first. So you do that by undertaking some solvent exposure monitoring. And then you can use online calculators. I know 3M provides a good one where you input the exposure concentrations and humidity and a few other items, and it'll tell you how often you need to replace filters. How do we monitor for solvents is the next question. So typically we set up people with personal monitoring equipment to measure solvent exposure. Usually solvents can be measured with charcoal tubes, so we use calibrated pumps to draw air through charcoal tubes. The charcoal collects the solvents in the air, and then the laboratory that we use will analyze the charcoal, extract the solvents from it and tell us what levels have been collected. And then we can do some calculations and work out what the airborne concentration is in the workplace and what that person is exposed to during their shift. Someone asked, are some solvents worse for you than others? Yeah, definitely. Some solvents are more hazardous than others. We can look at the difference between ethanol and phenol, and phenol is certainly much more toxic. Someone asked about workplace exposure standards and whether they're going to be lowered in the future. So what I can say is that workplace exposure standards are constantly being reviewed. So WorkSafe look at certain substances yearly. They'll select a list that they're going to look at, and they'll do a full review and take submissions on the substances. And if the health risk is found to be greater than the current exposure level, then they can be lowered. And you'll also see other notations added to substances like the ototoxic effects that I talked about earlier. And someone asked, what filters should I use on my mask or respirator to protect myself from solvent exposure? And organic vapor cartridges, as I said earlier, will mostly protect against solvents, but be aware that they won't protect against all solvents. And after a certain amount of time, they will stop filtering solvents. So you have to be aware of how long you can use them before you need to change the filters. And also make sure that the respirator system that you're using is effective to control the level of exposure that you have, so the concentration in the air. So that's all the questions we have for today. So again, thank you very much for watching this webinar, and we'll send through that follow-up email with some more information and a link to the webinar.